Boo, 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 we're recording. All right, sweet. Yeah, so join that Telegram channel and ask questions there, and I can answer them live. But this is Ethereum on tour. We're going to talk about Ethereum. Answer those questions in the chat so I can know how, first of all, are you a developer? Do you hold ETH? And have you deployed smart contracts before? This is a strange turnout where oh no, it's not strange. It's normal. I was going to say, I thought it looked opposite, but it looks like more than half of you are developers, and even more than that hold ETH, but less than half of you have deployed smart contracts. So kind of like a medium group where some of you have even deployed smart contracts. Probably this will be kind of boring for you, but I'll show you some cool stuff, even if you are super into ETH already. Really cool that 65% of you hold ETH, though. That's awesome. If you don't hold ETH, let's start with that. Rainbow.me is a great, simple wallet. Look at these fun rainbows flying all over the place. But you can get a Rainbow wallet. It's the one I use on mobile. It's super smooth. You can swap to all sorts of meme coins. Here is my Rainbow wallet. Let's see if I can get it pulled up. There's my Rainbow wallet. You should get one too. Great little wallet. It works across many chains. You can then connect your wallet and can talk to apps on your computer, but get a Rainbow wallet. I'll paste that into the Telegram as one of the first links. For the other 35% that doesn't have ETH, you should get a Rainbow wallet and get a little ETH in there. Okay, next thing, we were just talking about ETH.build. This is a fun little sandbox. Let me paste this into the chat too. Kind of like as we explore these concepts. Oh, no, unfurl. Give us the unfurl, bro. Let me see if I can do that again. Maybe I need the HTTP or something. Gotta have the unfurl. Let's see. Let me see if I can do better. Nope, no unfurl. I don't know. This is, oh, no, it didn't. This is like from, oh, there it is. It did finally. This is from like many years ago. I use this as a tool to teach, but like here is like a seed phrase, right? So this is how you custody funds on Ethereum. That Rainbow wallet that we were looking at just now will have a 12-word seed phrase in it. And this is an example 12-word seed phrase. We're just generating them randomly. But what the underlying tech is like an ECDSA key pair. So a key pair exists of a private key and then an address, and you can just generate those. You know, if you want to create a bank account, you have to go to your bank, you have to KYC, you have to do a lot of stuff to be able to create an account. On Ethereum, you just generate a big number. This is a 64-character hex string is just a giant number. And if you create a good random one, there's so many possible numbers that you could use all the computing power in the world to sit here and generate these and then check the balance. Like we could say balance, and we could plug this address in, and we'd have to plug in the Ethereum blockchain. There's lots of blockchains now, but you'd have to plug in the Ethereum blockchain, and then you get a value and you would check it, right? So you would do something like tie this button to that button. Oh, I can't. I thought I could do that. It's been a while since I've used this. Oh, here we go. We tie that to that. So then it's like, yeah, so it'd be something like this, right? We're clicking as fast as we can, generating Ethereum private keys, and we're checking the balance. It's always going to be 0. You're never going to find one until like the heat death of the universe. Statistically, you're never going to find one. So a really neat kind of concepts there is that you can create these private keys, and all you need is a private key, and then you send a little ETH to this address, and you sign messages with this private key, and you can interact with Ethereum. But how do these two things talk? Basically, a mnemonic is much easier to remember than this. Like if you had to remember this or have this like written down, it would be hella hard to like reproduce this. If you like wrote this down, you'd have to type it all back in. It'd be a lot of work. But this is easy, right? Like you could remember a 12-word seed phrase pretty easily, or at least like write it down somewhere. And so what we do is we make a 12-word seed phrase. We've got 12 words, and then we plug that private key. We basically we hash this, right? We take a hash of this thing right here, and then you get basically a private key out of that. And that's what's going on here. There's even an index. So it's like this with a 0. But this is really nice because then you can have just a 12-word seed phrase. It can generate any number of private keys. And that's what you will have if you have a Rainbow wallet or something. You will just have this 12-word seed phrase and you'll have to protect it. But self-custody is super hard. If you have this 12-word seed phrase and you leak it, it's gone forever. If you lose it, it's gone forever. So you have to be very careful and you have to take care of this thing, and you have to make sure that if it's on your phone and your phone goes in the toilet, you can come back and get this 12-word seed phrase and reproduce your account. So self-custody is hard. It's getting easier with things like smart contract wallets and passkeys, but the state of the art right now is basically get a Rainbow wallet. You'll have this 12-word seed phrase that you need to protect. You'll use a private key to sign messages, and your address is kind of like your public address, and that's where people send money and stuff. Okay, cool. So now that you can have an account and you can send money around, yes, that's cool. That's like what you do with a blockchain. But more importantly, and kind of more interestingly, Ethereum is a smart contract platform. It's a platform for building apps that are decentralized. And kind of the two main features of decentralization, like why you want something that's decentralized, first of all, it won't fall over. It will be up forever, right? Ethereum has been up for 10 years. When you deploy an app to Ethereum, it will always be there. And you can ask any node on the network about the state of your app and it will give it back. So like the first thing you could do is just deploy like canonical information. If you need something that can always be up all the time and anyone can get to it, you can deploy a small smart contract with that information in it and it'll be there forever. And anybody can ask it, any RPC on the network, any one of those peer-to-peer, thousands of peer-to-peer nodes on the network, you can ask them, what's that information in that smart contract? And this thing can provide that back. Writing to that smart contract is a little bit more expensive. You have to pay for it, but reading is cheap and free. So smart contracts aren't just like, putting canonical information. You can have lots of execution and code in there, right? So let's go look at a smart contract. One of my favorite ones to show off first is the WETH contract. It's wrapped Ether. And so this smart contract has some very simple code. It's basically a token. So it's an ERC20 token. So we keep track of people's balance and you can transfer it around. But it has these extra two functions. There's a deposit function and a withdraw function. So basically you can deposit ETH into it and it will give you back an ERC20 token. And so there's this one line of code that's very, very simple. If you're a programmer, hopefully that's big enough. I know there's like on a big screen there, but hopefully that's big enough. Basically, we're tracking the balance of anyone. And this happens to update the balance of the sender, the person who called this function. And they're adding the value, whatever you passed in. So when you call deposit, you're going to call it on this address, right? So this token, this chunk of code has its own Ethereum address, and you call a function on that Ethereum address. Or in fact, you can just send money to it and it will call this for you. But it calls this function and basically updates this value. So every smart contract has some execution code and some storage, and it's basically updating this storage record and it's updating your balance. It's just taking whatever money you send in and keeping track of it, and then sending you, it'll mint you a token when you do this. And then whenever you want to turn that token back in, you can call withdraw, and it will subtract from your balance. So I can put $5 in calling deposit, and then later I can call withdraw for $5 and get my $5 back. So it's just an address that has code behind it. But if you look at this, it's pretty crazy. This little contract right here, this little chunk of code has $10 billion in it. That one little deposit function there that's right here, this has been called with more than 10 billion. There's currently $10 billion in it. So this is really neat because as a programmer, you're literally programming money. You're programming how money flows, and you're writing little programs that actually have an address that send and receive money, along with executing and changing local storage and doing lots of stuff within that contract. So this leads to, and please ask questions. I'm watching the Telegram channel. If you have questions, please ask questions. please hit me up if you have any questions, so I can if you're lost on anything, or you even have like a quick aside, please drop it in the chat and I will respond. But this leads to, okay, sweet, it's decentralized, it's always going to be on. I guess I never got to the second part of that. It's always on, and it's tamper-proof. It's censorship resistant. Basically, anybody can always get to it, and no one can change it or take it down or tamper with it. And those two properties are the most important. So you can deploy code, it's always going to be there, it's always going to be up, and it's going to do exactly what it's programmed to do, and no one can change it or take it down. How do people find this address to call this function? Cool, good question. Usually what I do to find the WETH address is literally Google like WETH address Ethereum. But you're right, there is kind of this discoverability problem. There is no like app store. And actually there is. I think they're working on putting like an app store up here somewhere. It's probably buried in here somewhere. But there really is no like canonical place to go see all the addresses of Ethereum, just because there's so many of them. It takes me like 5 seconds to deploy, and like $1 to deploy a token on Ethereum. So really you kind of have to Google it and hope Google has the right address. But that's how you would do this. You would Google wrapped ether. If you're interested in like different tokens and how you find them, look in your Rainbow wallet. If you go to a Rainbow wallet and you go to I don't even know. If I go home, I could probably like find like trending tokens and my different positions. Usually there's like a group chat. Everyone has a group chat with their crypto buddies. And when a new token comes out, they go, hey, check out this new token. If I had to like randomly pick one that I would have in my group chat right now, it's Punk Strategy. And this is like strategy. This is like a weird thing. But imagine we're in the cabal right now, and I'm giving you some crypto alpha. I don't really know. Like, this is not investment advice. Don't actually buy this. But this is a really cool system. So it's like the strategy, the the Bitcoin, the MSTR, the Bitcoin strategy, where they're buying and selling Bitcoin. Michael Saylor, that guy. It's like that, but for CryptoPunks. CryptoPunks are like the most famous NFT. Basically, this thing has this, you buy the token. So if you own Punk Strategy and you buy the token, and as it gets enough of the token money built up, it buys CryptoPunks, and then it puts them on sale for like 1.5 the current value. And then it's like there's a Uniswap v4 hook. So every time you swap, it's like charging fees, and the fees and the Punk's sale price are then like sold and then used to like burn the token. So there's like this sell pressure or this buy pressure on the token. So I don't know. That's the alpha. I'm just pretending like we're in the chat. So you could just go to your Rainbow wallet. Don't do this. This is a bad idea. And you could search PNKSTR, I think. Yeah, there it is. There's Punk Strategy, and you can buy some, and it'll probably be worth less tomorrow. Could be worth half as much. Could be worth zero. But this is how I discover things. Usually, it's like in chats or following crypto Twitter. And crypto Twitter is like a whole nother thing. Like crypto Twitter is where a bunch of people post stuff, and it's kind of a cesspool. Crypto in general is a cesspool. Everyone's trying to steal your money. The fact that 12-word seed phrase can leak and someone can take all your money. So people are always constantly trying to like get on a call with you and have you download something. And as soon as you download something, your wallet and money is gone forever. So be very careful. Don't take investment advice from jabronis on the internet like me. This is all a do your own research thing, and you should spend a lot of time researching this before you buy anything. But just giving you an idea of how I discover things. A lot of it is following people on Twitter, and then like group chats with friends and asking them about things. So hopefully that answers the question. And then like, how do I find the address? A lot of times I'm just Googling it. Let's see if we could find Punk Strategy address Ethereum. Let's see if we can find the actual address of the token. Yeah, there it is. And then Uniswap v4, there's the hook. So this is probably the token right there, I bet. Yeah, cool. And this is probably the, well, you see that chart? That's looking pretty green. that's what we talked about in the Cabal chat. Okay, here we go. Let's close this out. No more of this investment advice stuff. We're developers. We're building on Ethereum. We're building unstoppable apps. I'm with the Build Guild, and we make this thing called Speedrun Ethereum, and we do all these things like build tools and have onboarding batches and everything. But Speedrun Ethereum is really a good answer to what kinds of things do I build on Ethereum, okay? So I understand Ethereum is cool. I'm programming money. There's this WETH contract with $10 billion in it. If I deploy an app to Ethereum, it's going to always be on and no one can tamper with it. And it's going to run exactly how it should without even me being able to shut it down. That's really cool. But what do I build on Ethereum? What kinds of things actually have product market fit, right? So NFTs had their time in the sun, but they really kind of have faded out, except for CryptoPunks and some other ones. Mostly, if you think of NFTs, think of them like credentials, like your passport. That's what NFTs are going to be in the future. You will get issued an NFT and it will prove that you were at an event or that you did something or that you live in a certain country, and that NFT will allow you to have access to other things. So think of it just like a credential. But this staking app, this challenge one of Speedrun Ethereum, and let me just paste this into the chat. If you're a developer, you could probably fly through these challenges, but they're going to help you understand what kinds of things you build on Ethereum. Specifically, this is a staking app, and I don't mean staking like we have running here. This is like a validator node. This thing is staking 32 ETH and making blocks on the Ethereum blockchain, not staking like that. What I mean by staking is staking oh no, people need to be let into the meeting. Hold on, let me make sure. I'm sorry. Oh, I'm sorry. Yes, 2 people need to be let in. Got him. Sorry, Hannah. Sorry, Andre. My bad. I will watch this a little closer next time. Sorry, Andre and Hannah. Thanks for joining us. Welcome. Oh, there's more. Admit. Feel free to come on in. We also have a recording, so you can go watch the early part of the recording later. I'll post it in the Telegram. Oh, everyone's joining. Yes. Great. All right. I will listen. That made like a little ding dong that time, so I can hear when people join. I will try to catch that next time and not miss that. I'll keep that up. Oh, for the new people joining, join us in this Telegram channel. If you scan this QR code, there is a Telegram channel, and you can ask questions in this channel. And also there is a small poll at the top asking, are you a developer? Do you hold ETH? Have you ever deployed a contract? Answer those questions so I can understand who I'm talking to. Looks like I see them moving around. Man, the have you deployed a smart contract has flipped. It's now 50. Oh, now it's back to 50-50. Now it's back to 52. Wow, good answers in there. It's good to have people like live. I saw it go 50-50 there for a second. But join in, answer those polls so I can kind of customize this content. For the hardcore ETH folks that already know all this stuff, sorry, I'm going kind of slow. Yeah, here we go. Back to Speedrun Ethereum. Your first app that you should build is a staking app, and not staking like validator, but staking like getting a bunch of people who don't trust each other to stake towards some goal. Let's say we were trying to raise money, and let's say we wanted to get like, if everybody on this call chipped in $10 and then we went and bought a Nintendo Switch or something. Think of that, but think of it in a very big scale. Like say we wanted to buy an island. This is good. I've never used this analogy before. I'm going to start using it. We want to buy an island, and it's so big that lots of people will live on this island, so many that we don't trust each other, okay? If it was just us on the call, you could kind of trust me or maybe Winnie, and you could say, okay, Winnie, you're going to collect the $10. All of us are going to give you $10. You go buy the Nintendo Switch. We kind of trust you to do all of those things. That trust will fall apart at scale, right? You can't trust everyone on the internet. In fact, you should almost trust no one on the internet, right? Unless like a lot of reputation and other things follow them, like don't trust people randomly. It's a really bad idea at scale. There are way too many humans in the world to trust everyone. So imagine that. We're trying to buy an island. We don't trust each other. Your first Ethereum smart contract could be to coordinate the purchase of this island, okay? So imagine we all need to get, maybe we need to get everybody to pitch $1,000, okay? And we're gonna go buy this $1 million island or something like that. And we have to get all of us together to go buy the island, but we don't trust each other. And this is really kind of the kind of thing that you would build on Ethereum, basically building a global scale co-op. You know how co-ops are like these kind of like hippie, let's all get together and we all trust each other kind of company where there's no centralized control? That's kind of what we're building here, but for like global scale. So we're creating a co-op that's going to own this island, and no one's going to be the owner of the island. Like, we're all the owner of the island. And as this island earns revenue, we want to split that revenue out to all the owners, right? We're this island co-op we're all going to live on. But also we don't trust each other, right? So this is kind of the kind of thing you're going to build on Ethereum. You're going to write like a simple set of rules that an adversarial group of players can use to work together. You're building a coordination mechanism, and you're allowing people that don't trust each other to coordinate at scale. Thinking of that WETH contract, they can trust the WETH contract because they can see the code. They know exactly how it works. It's got $10 billion locked in it. They know that if they put in their $1,000, the code is gonna work exactly like it's supposed to. So in a decentralized staking app, you would build something like a state machine. You would have a deposit phase, and you would be in the deposit state, and you would allow everyone to deposit their $1,000. Then at some point, you need to switch to either a success or a failure state. And you would either decide, did we collect enough money? And if you did, then you would switch to the success state and you would go buy the island. Or a failure state, if you fail to coordinate, then you would split the money back to everyone. And this is kind of a key insight here, is that everyone puts their money in, they trust the code to do exactly what they can do, no one can steal the money, and if you're not successful in buying the island, eventually everyone gets their money back. And that's how you need to build this. It's a massive multiplayer game that's played globally at scale with money and digital assets, and you can just trust the code. You don't have to trust other people. And that's the kind of thing you'll build on Ethereum. So what are the first apps that are really hot? Well, tokens. Basically, tokenization was like the biggest, like the first killer app of Ethereum. People needed to be able to have some unit of account and have a transfer function. Going back to that WETH contract, it kept track of your balance and it let you transfer it around. And that killer app was really useful in the tokenization of all sorts of digital assets, along with meme coins and shit coins and everything else in there. There were things like Pepe, which was just like a frog, a picture of a frog, and you were buying that and it went up and down, and it was mostly just a speculative asset that you were buying. And if you got in early and sold before it crashed, you made money. But there's kind of like this cycle of the token sale where if you held it too long, you lost money, which is bad, and you shouldn't do that. And kind of speculation is kind of a shitty part of crypto. Remember, crypto is cryptography. Crypto is cypherpunks. We're building these apps for the future where anybody can use them to trust each other. But also some of the product market fit is, money and speculating and gambling, and that's just part of it. But in challenge 2, you'll build a token vendor, which means you'll deploy an ERC20 token, and you'll also deploy a second contract that lets you sell that token. And also, I think it buys it back, and that teaches you the approve pattern. So basically, there would be one smart contract that would be the token. It keeps track of your balance and lets you send it around. And then another contract that sells that token at a certain price. So what happens is when you go to buy some, you kind of go to the vendor contract and put in some money, and then that vendor contract goes to the token contract and transfers it to you. So you're learning things like contract to contract interaction. You're learning things like the ERC20s and the approve pattern. But go check out the token vendor. The dice game is another interesting one. If you're trying to build a game, or you're trying to do anything that you want to have randomness involved, it's actually really hard on a public deterministic blockchain. A lot of people, what they do, like when they wanted to do randomness in NFTs and have NFT mints be kind of random, where you would get a more rare or less rare NFT, the way they did it, which was bad, was using previous block hash. And you can actually game that. And in this challenge, there's a dice game, and you pay money to roll the dice, and if it rolls a certain thing, you win the money. And what you'll do here is you'll create a second contract that looks ahead at the block hash and figures out if it's a winning block hash, and basically only pays to roll if it's going to make money. So you kind of attack this dice game. Okay, so now building a DEX. This is when we really get into interesting apps. Once we have tokens and we can send those tokens around, we can buy those tokens in a vendor contract. What you really want to be able to do is swap those tokens in a fully decentralized way for other tokens. And you need the price of those tokens to be dynamic based on market fluctuation, right? So the way you would do this before was using a centralized order book. You would sign a message that says, I have token A, I'd like to get token B. Someone else would come along with token B, and they'd put your transaction on chain, and they would send in token B, and it would swap, right? So it was using a smart contract, but there was a centralized order book. That centralized order book can always fall over. There can be censorship. All of the things that come from centralization, those bad things like censorship and just basically like the server falling over, all of those things can happen with a centralized exchange, and they did. They could also get hacked. Mt. Gox got hacked. You don't want that to happen. So what you want is a fully decentralized exchange that's basically just the code, and the code lets you swap. And the key insight into how to build that is you do it by loading up reserves of the token in the smart contract. So the DEX contract will hold a whole bunch of token A and a whole bunch of token B. And you'll come along and you'll put in some token A, and it will tilt the scale, right? And it uses a constant product to figure out the price, and it's just based on the ratio. So imagine putting in token A and the tokens kind of sway this way. And what you do is you take out some token B to even things out again. And that's basically how a DEX works, is it has a whole bunch of reserves of both. And then there's a formula that tells you what the price is, and it's at the ratio. You put in some of token A and you get out some of token B. And that lets you swap in a fully decentralized way. Now, here's the interesting thing. This is what's called a hyperstructure. And if you look up hyperstructure, it's really cool. It's from Jacob from Zora. He talks about the code of Uniswap, the original version of Uniswap that was one of the original DEXs deployed to Ethereum, is really this beautiful code. And if you think about it like a vending machine, right? At your school, you guys have a vending machine. There's chocolate and there's money. You put in money, you get some chocolate. This isn't a direct one-to-one analogy, but imagine this. Imagine that someone put a vending machine in your school, and anyone can provide the liquidity, right? It's not just some dude stocking it and getting the money, but basically anyone can come with chocolate and money and put it into the vending machine. Maybe the vending machine has like an interface on the back, and it says put in your liquidity, and that goes in. And then you get basically a token or a slip back that represents your liquidity inside that. And what that does is every time someone swaps, every time someone trades money to chocolate or chocolate to money, there's a small fee that it charges. So that is what incentivizes you to provide the liquidity. And that's what they did with Uniswap. Basically, they deployed the hardware that it's like an empty vending machine, and they wrote the rules correctly to provide the incentives for people to check in. Or I'm sorry, the incentives for people to provide liquidity. We'll talk about checking in a second. I'm getting ahead of myself a little bit. But you need to write the incentives correctly to make something on-chain work. And that's how this DEX works, is the more liquidity that's there, the better the swaps. And to get people to provide the liquidity, to incentivize them to put the liquidity in there, you need to have a fee on the swaps that goes to liquidity providers. So there can be thousands of people that all provide chocolate and money, and then there can be thousands of people that come along and swap from chocolate to money or money to chocolate, and it leaves a little bit of fee behind. But if I have $1 and I'm hungry, I can put the $1 in and get a chocolate bar, and I'm happy because I've got my chocolate bar. I don't care that there was an extra like penny that went to the liquidity providers. I paid my $1 and I got my chocolate. But if you're somebody that has lots of dollars in chocolate and you want to earn money on those, you can put those into this vending machine and earn. You know, you have $100 and 100 chocolates, and you put those in there, and at the end of the day you have, you know, $102 and 102 chocolates or something along those lines. So this idea of a hyperstructure is really interesting, because you can think of the person who builds the DEX as just writing the rules and creating the correct incentives and allowing people to come in there and use it at a massive multiplayer scale. And with the incentives aligned, you allow tons of people to coordinate and use this thing. And even the person who deployed the chocolate can't even, or deployed the vending machine can't even stop it. And that's a really cool thing about building on Ethereum. And this challenge 4 will teach you how to build that DEX. Okay, speaking of checking in, if you have any questions, first of all, drop them into the Telegram. Hopefully I'm not mansplaining too much here. I want to get into checking in, and even like a cron job. Kind of making the change from Web 2 to Web 3. When we think of a Web 2 cron job, for the nerds in the room, a cron job is like a thing that, for the non-nerds in the room, I guess, a cron job is a thing that you run on a server. You tell this server, every night I want you to roll the logs. Oh, I see other people getting invited. Let me make sure. Let's throw the QR code up there real quick. If you just joined us and you haven't gotten into the Telegram channel, please do. Here's the QR code. Join us there. Okay. Oh, let me put it back here. Okay, let's leave the QR code. Okay, cron job. You want a task to run on your Web 2 system. Basically, you just tell a computer to run it every night. So what if you have something similar in Web 3? What if you have a smart contract protocol and you need to roll the, I don't know, compound the interest. Let's say it's an interest-bearing asset, and every night at midnight you need to compound the interest. So to do that, it's not just about writing the code. You do write the code correctly, but the insight here is you also provide the correct incentives, okay? So what you do is you write a piece of code that says, at midnight, anyone in the world can come in here and poke the button. They can hit the button to roll our logs or compound our interest or anything like that. They can do the action that you need to guarantee to run. And guess what? You provide an incentive on top of that. You say, whoever gets in here at midnight gets paid $100 for pushing this button, right? So it's kind of like, let's say the vending machine every night needs to rebalance its assets or something. So someone needs to come along and just push the button on the vending machine, and whoever pushes it, it prints a $100 bill out for them, right? And so if that's the case, there's going to be a lot of people standing around at midnight waiting to poke that button, right? If you imagine that at a global scale, that's how you run a Web3 cron job, is you basically write the rules correctly to say anyone can run this function, and only one person every 24 hours can run it, and whoever runs it gets paid for it. And when you create an incentive like that on an open source, fully public blockchain, what you get is the effect of this thing is going to run no matter what, because people all around the world are incentivized to run it. They'll have it on tons of different machines with different operating systems, with different security and internet and everything. So even if half the world is blowing up, someone's going to be around to poke that button to run that service. And with the correct incentives and the correct code, you get a system that basically runs forever and always runs. And that's really important in the Web3 world. So that brings us to lending. Once you've got tokens, you can swap, you can send the tokens around, you can swap token A for token B, all in a smart contract. Let's say you want to do lending, you want to borrow some tokens. Usually when you're doing this, it's speculative, right? Usually what you would do in an over-collateralized loan is you would put up $200 and you would borrow $150 of some other token, effectively like shorting the token. You're borrowing the token at the current price and you'll sell it at the price later, or something along those lines. What you can do is even loop it where You put in $200, you get 150 back, you swap that back, provide it as collateral, borrow 75 more, swap that back, put it as collateral. So there's this whole looping thing. It's how people speculate on tokens, but what this does is allow people to kind of like lever up and gamble on these tokens. Again, speculation, kind of shitty, not so cypherpunk, but also product market fit. We're talking about what people are doing here. So first of all, like, why over-collateralized loans? Why do I have to put in 200 to only get out 150? The reason is you can't trust anyone, right? And the way you do this is you put in 200 and you give out 150. And if the 150 ever becomes worth more than the 200, or if you can imagine the price of ETH starts to go down, and all of a sudden that ETH is only worth 180 for that 150, and then all of a sudden it's worth 170 for that 150, and it's headed down, you need to do something, right? And that something is called liquidation. Basically, what you do is, at some ratio, you allow anyone to poke the contract and say, liquidate this person's loan. And so over-collateralized lending works because you can put in an over-collateralized loan, get a smaller amount out, and go play with it, speculate however you want to do, even go, buy a car and then eventually pay it back as you use that car to do some utility. There are good reasons to take a loan, but most of it is speculative. As long as the 150 that you borrowed is worth less than the collateral that you have up, you're good. But if that collateral starts to become worth less, someone's got to liquidate that loan so the protocol doesn't go underwater. And that's how you build an over-collateralized lending system. You allow people to put in collateral, take out an over-collateralized loan, and just have a liquidation mechanism. And you'll learn about that at Speedrun Ethereum on this challenge. That leads to stablecoins, where you use this whole thing plus an oracle, which is another thing down here to keep the price. And there's some incentives on both sides. There's incentives for holding, incentives for lending. You're constantly adjusting those rates to keep the price right and keep the sell and buy pressure equal. There's prediction markets, which are really cool. Basically, you're basically allowing people to bet on some future outcome. Will this happen? Yes or no. You can buy yes tokens or no tokens, but you're basically guaranteeing that in the future, you're going to rug one of them for the other one using an oracle. We saw this with Polymarket in the US election in 2024. Will the government shut down? And this is really interesting because this is very topical. So we can see kind of like when the shutdown will probably end. And this is how people are betting, right? So, wow, 33% say it's going to last longer than 2 weeks, right? 30% say it will happen in the next week. And a very low percentage of people think the government will not be shut down. Like, basically they're saying, oh, this is really interesting, right? This is some really interesting information. I would have guessed that a few days we're going to be done with this thing. I don't know what I'm talking about. And people who do know what they're talking about have put their money where their mouth is. And the most likely scenario is basically the government will be shut down until after October 15th. And if you don't agree with that, or you think you have more information, you can get in here and put your money where your mouth is, and you can earn a bunch of money if you get it right. So that's how prediction markets work, is you're betting on some future outcome, and that allows everyone to see this aggregated view of those outcomes and the likelihood of them happening. Okay, CK voting, multisig wallet, there's a lot of cool stuff here. Go to Speedrun Ethereum to learn how to build, to learn what to build. But I want to get into how to build here in a little bit. I want to show off Scaffold-ETH and how to build. We'll do that in just a second, but let's do a vibe check. Let's see if everybody's still awake. You might be asleep after all that mansplaining. So I've built a vibe check here. I just vibe coded this app a little while ago. It asks, how's the vibe? If you scan this QR code, let me make it bigger. If you scan this QR code, you can vote. You'll show up here. We've got 2 people joining. We've got 4 people. We've got 5 people. We've got 6 people. Great. Everybody's joining. Let's do a vibe check real quick. How are the vibes? Let me know how the vibes are out there. Here, I'll even paste the slop computer into the chat real quick. This is actually my vibe coding station for my kids. We get on and we make little games, and they come up with a game. And normally I wouldn't just build this game, but since it's so easy with AI, I just prompt the AI, and it builds a little HTML game and we play. But I use it also for demonstration. So how is the vibe? Whoa, they're 100% good vibes, 0% bad vibes. Okay, there's a reason for that though. When I vibe coded this game, I decided to add a little censorship to it. Since this is a centralized vote, right? I made it so if you vote bad, it gives you some like database error. Table bad vibes has been deleted. So basically this is censorship. It's a really silly example of this, but it shows how censorship can happen. And this is like one thing, right? Censorship or changing the vote. This can happen in a centralized server, but also this can happen. Watch this. The server could just fall over, right? I could actually accidentally restart the server and now it's back to 0, right? So these two things are really important. Both I can censor things and I can change the vote, or I can even have the server fall over or restart it on accident or fat finger something. And this is why you build on Ethereum. Things can't be censored. They always run exactly like they're supposed to, and they never go down. No one can fat finger or turn it off. And that's a really cool feature. Okay, we got a question. Thank you so much for posting the question. This is awesome. How do you envision the future for average non-programmer consumers to safely interact on-chain programs? Yes, okay. So we saw the bytecode of the WETH contract. We saw the code. If you really wanted to investigate that, you'd have to be a really good programmer. You'd have to know about all the different hacks. To be able to like just look at a smart contract and really do the due diligence on it is like very hard. Like probably like only hundreds of people in the whole world can really do that. Probably like less than 100 people in the whole world can really do that. So how do we get to the point where we can do this safely and scalably? I think, first of all, lots of audits. Things eventually get lindy with lots of money in them and lots of people trying to attack them every day. Like if we go back to that WETH contract and we think of it like, let's go to that WETH contract again. We think of it like a bounty. There's basically a $10 billion bounty. If you can figure out a way to get the money out of this contract, you can get $10 billion. That's some serious FU money. And the point here is that that money has been here for 10 years and no one's been able to steal it. So even though this contract is solid and it's been audited, and maybe even you use like an AI audit or an AI agent to audit it and thousands of other auditors, you never really know until you really put it out there and put a bunch of money in it and then have lots of other people trying to steal it. And even to this day, maybe there's a way you can get the money out of here, but there's a $10 billion bounty that says you can't. So in this interesting way, as these things kind of get more money and have more people trying to hack them, eventually we're kind of pretty sure that this thing isn't going to get hacked. So first of all, that like auditing and a contract getting lindy and people posting it, posting the code for it, and everyone also trying it, and there being this giant bounty for you to break it. But on top of that, like regular users will probably not even use something like a rainbow wallet. Like that 12-word seed phrase that we talked about here, the fact that if you lose this, it's gone forever. If you leak this, it's gone forever. This probably isn't for everyone. I don't think mainstream audiences are going to use private keys. I think we're kind of like at an early point of that. And the thing I think I want to point to is HTTPS. See this in the browser, that HTTPS right there? I can't even zoom in. Thinking of crypto as in cryptography, everyone uses HTTPS, right? No one uses HTTP. And as soon as we got HTTPS, we could do things like put in your credit card and know that no one was man in the middle stealing stuff from you. And this is really important, but no one gives a shit or cares about it. They just know that there needs to be that little green locky guy, right? You need to have that little green locky boy to know that like this is secure and the stuff that I'm doing here in this browser is safe. And we don't need to know how the cryptography works. We don't need to know that there's an asymmetric handshake and then symmetric encryption happening there. That's all what's happening underneath the sheets. All we need to see is there's a little green locky boy and so I can put in my credit card. That's what mainstream audiences need. So I think we're going to get farther abstracted from the 12-word seed phrase, and it'll be probably things like passkeys and crypto on your phone. I don't know if you've used a passkey yet. They're really smooth. Well, they're almost really smooth. The OSs need to get better at it. But what you'll do is you'll go to your Coinbase, or you'll go to your bank, or you'll go to some on-ramp, and you'll say, I want to move money into crypto, and it will say, cool, you need to create a wallet, fingerprint. You'll do a fingerprint, and that fingerprint will be the owner of that wallet. That wallet will be a smart contract. It will probably have some kind of social recovery where your bank can also send a reset and add a new account or something like that, where you have some guardians, and you can remove those guardians as you need, and you want to be more cypherpunk. But then when you go to make a transaction, you'll go to Uniswap, and you'll say, I want to go buy Fartcoin, and it'll say, throw in your fingerprint, and you'll fingerprint, and you'll buy some Fartcoin, and you won't have to worry about 12-word seed phrases and losing it. So both contracts need to be audited a lot more, and self-custody needs to improve. But as both of those things happen, I think then mainstream audiences will be able to safely come on chain and interact. But for now, it's still the Wild West. We're still writing 12-word seed phrases and putting them in our underwear drawer. That's okay for now for small amounts. By the way, if you have more than a couple $1,000s in your Rainbow wallet, you should look at a Gnosis safe. It's basically a smart contract that has multiple signers on it. What you should do is have maybe your Rainbow wallet, and then maybe like a browser wallet, and have 2 different 12-word seed phrases stored in different places. And then what you do is you have a Gnosis safe that's like a 2 out of 3 multisig, meaning you can send money to it really easy, but to get the money out, you need to have 2 out of 3 signatures from those accounts, right? And what you could do is just have like a couple of your friends as like recovery people, and if you lose one of your wallets, then you could take your signature plus one of your friends' signatures and add a new wallet in. So a Gnosis safe or a multisig is a good way to custody your funds. Eventually, we'll have really nice passkey smart contract wallets. There's also hardware wallets, but the user experience is garbage. But they are like possibly safer as long as you keep that 12-word seed phrase somewhere safe. It always comes down to the seed phrase. There's kind of like this funny meme of the person getting their hardware wallet and taking a picture of it, and in the background is their 12 or 24-word seed phrase, and they just took a picture of it, and everyone on the internet can see it, and they stole their money. So self-custody is hard, for sure. Okay, let's go build something really quick with Ethereum. Sorry, I've been yapping for so long. Drop your questions into the Telegram. Also, like, in 2 weeks from now, if you like wake up from a fever dream and you have a great question for me, just drop it in this Telegram channel. I'll be here years from now, hopefully, and I'll have all these Telegram channels. And if you have a question, feel free to ask at any time. But we've learned what is Ethereum. We've learned what kinds of things you put on Ethereum. We kind of have the why. We're deploying these always on, never tampered with, never censored apps. So let's go through the how. How do we build on Ethereum, right? Okay, let's see here. What I'm going to do is I'm going to go to ScaffoldETH.io, and I'll paste that into the chat. And I'm going to run this MPX, and I'm going to call this the how. We're gonna learn the how right now. Okay, so for you people, I think about half of y'all have deployed a smart contract. You probably used Hardhat or Foundry. Either of these you can use. I just pick one randomly. Okay, we're going with that one. Foundry is probably the one that's more for the hardcore cracked engineers because they can run all their tests in Solidity and it's faster, it's written in Rust. Hardhat is a little bit more user-friendly. It was to the game earlier, so it kind of like still has some projects that work on it. But Foundry is kind of the favorite. Hardhat is the second place. But just like everything else in the space, there's a lot of diversity. We have client diversity where you have a Reth node or a Geth node or a Prism node or a Lighthouse node. There's 6 different implementations of everything. So if one of them has a bug, not everything dies. And so same thing, we have Hardhat or Foundry. Both are great. If one of them decides to start extracting from the space heavily, everyone will switch to the other one. And they basically do the same thing. Smart contract orchestration, deploying and testing. Okay, so we've got everything installed from Scaffold-ETH. We're going to CD in. We're going to do yarn chain. What that's going to do is run a local blockchain for us. So now we have a local blockchain and we have all these accounts loaded up. And then we'll do a yarn start. That's going to fire up a front end. So what's unique about Scaffold-ETH is it has both the smart contract interaction orchestration and the Next.js front end, and they're already all wired up, which is really handy for you to be able to tinker with it. And then what we'll do is we'll do a yarn deploy, and that's going to deploy our smart contract to our blockchain and let us tinker with it. And let's go ahead and open up Cursor. Okay, so I've got my cursor here, and we can go look at the code. Specifically, there's two packages, right? There's our hard hat or our Foundry, and then our Next.js. The first thing we'll do is go look at our smart contract, okay? So here is an example smart contract. It's probably way too small for anybody to be able to see it, sorry. But basically, this smart contract is like a greeter smart contract. There's this storage called greeting, and it's a string that's building unstoppable apps. And there's an owner, and the owner can withdraw money, and people can pay money to set the greeting, but they don't have to. There's no requirement to. And so that's it. Basically, anybody can update this greeting, and if they pay for it, an owner can withdraw the money. Something simple there. Ooh, kind of a general question about ETH speedrun you showed, but what patterns or design choices show up again and again in these trustless systems? Yeah, I think I really touched on that when I was talking about the staking challenge. First of all, someone's got to poke it. Nothing is automatic, and you have to build your system like a state machine. And to move from one state to another, someone has to make the transaction to do that, and you need to incentivize them to do that. And the other thing is you're building a massive multiplayer game for an adversarial group of players. I think those are the real aha moments that you'll have. And when you go through speedrun, you'll see this. Basically, you're building a coordination mechanism for people who don't trust each other, and that code is going to run exactly like it's supposed to, but it's not automatic. So someone's got to like poke the code to do certain things, and to make them poke the code, you have to build incentives. With the DEX, to make swaps work really well, you need to have lots of liquidity. So if you want to, incentivize that behavior, you need to add a fee to the swap to pay the liquidity providers. Hopefully that's kind of giving you the hints there of like the patterns that you see all the time. Okay, let's build something really quick. We don't have very much time. Thank you for the question. Keep dropping questions in the chat. Here's our smart contract. We can interact with it. This is Scaffold-ETH. This is the front end. The smart contract, if we go to the debug section, we can kind of see the smart contract. We can see the address that it's deployed to. We can see that it doesn't have any money in it. Here's the read functions. Here's the write functions. So yeah, I guess we could say hello world. Okay, so this isn't, what I want to do is make a transaction, and we want to set the greeting to hello world. Thing is, I don't have any money, and now's a good time to explain the wallet. Now, normally you would connect your Rainbow wallet or something like that. But when you do that, you have to have it on the right network. You have to have the right chain ID. There's all sorts of stuff you need to do. And in development, it's way better if you just have a burner wallet. So this burner wallet is just one of those private keys we saw earlier that's just stored in local storage. And what that gets you, let me go to the faucet here and load up with some free ETH. Now I got like $8,000. And then now when I hit hello world, I don't get a wallet pop up. I don't get a change the network. It just sets the thing to hello world. And if I keep clicking that, I'm just making transactions here. Now our counter is up to 6. So when you're on localhost and you're testing smart contracts, you're building something quickly, these burner wallets let you tinker with things very quickly and set things. Okay, we don't have too much time left, but here is our greeting. We're able to set hello world. Let's talk about one weird thing about smart contracts is ETH versus WETH. So if I were to pay 1 right here and hit send, we're actually paying 1 WETH, which is like worth a fraction of a fraction of a fraction of a fraction of a cent, like 0.000000000000001 cents, right? Is 1 WETH. It's like 10 to the 18. So it's very small, 10 to the 18 ETH. So the reason why we do this whole ETH versus WETH thing is for decimals. If we want to have a decimal here, like 0.001 ETH, which is like $4 right now, this won't work. It actually fails because the EVM doesn't mess around with floating point math. So as a developer, you need to know that if you want to do this, you have to multiply it times 10 to the 18. So this is what you actually send to the EVM to execute. And then when you get it back, you display it to your users as 0.001. But since this is for the developer, we kind of have it here, and you'll have to figure it out as you go. Okay, we're literally programming money. Let's do something interesting here. We have a greeting, and we're saying if someone sends in value, it's premium. Let's actually charge people, right? Let's do a unit 256 public price, and let's set it to 0.001 Ether, and then let's put a require statement. Basically, we're requiring a certain thing to be set, and if it's not set, if it's not true, then we revert, and everything rolls back. If we had done some things within this function, like swap some tokens, those tokens would swap back. Like, it basically reverts everything when you do this. So we're going to require that they pay the price. And then we're going to do something really interesting. We're going to say price equals price times 102 divided by 100. Okay, we can't do 2%. We can't do 0.02. We can't do decimals. So what you do is you need to do kind of a numerator denominator trick. But what this is going to do is increase the price by 2%. So there's, oh man, I can hear people next door. Hopefully that's not too loud. So you can set the greeting. You have to pay to set the greeting. And when you do, we're going to increase the price on a price curve by 2% each time. And let's go deploy that. We write the code, we deploy it, we go tinker with it. Whoops, I did the wrong thing here. We go tinker with it in Scaffold-ETH. Okay, let's make sure this deploys. It should go. There we go. Now let's go back over here, and let's set the price to hello world, but we're not going to pay anything at first. It's going to tell us something like insufficient payment. You've got to pay, yo. Okay, so then we pay this, which is the same thing as doing 0.001 and multiplying it times 10 to the 18. And we hit send. Actually, there we go. It worked, right? We paid the price. We paid at least, it was greater than or equal to the price. But did you see what happened there? The price went up by 2%. Now, if we try to pay that again, it's going to say, you know, insufficient payment. We have to pay this new amount. And then once we pay that, it goes up another 2%, right? See what's happening here? So you can code this kind of stuff right into the logic of your contract. You can imagine like royalties or a split when someone uses something. You just, you know, this address gets 2%, this address gets 98% or something like that. And you just bing, bong, boom, program that up. We're literally programming money. Okay, there's a question here. Do you think agentic coding assistants are sophisticated enough to develop secure Solidity contracts? Maybe not right now, maybe not sophisticated ones, but they will soon. We're going to reach a point when computers are smarter than us. Like my laptop right here is going to be smarter than me in a couple of years or a year or 6 months, who knows? So that's going to happen soon. Most people like argue with me and say that's not true. Maybe it's a hot take, but I think absolutely. And let's do that, right? Let's finish this whole talk by doing this vibe check, right? Let's do a vibe check, but let's do it in a smart contract. And let's have an agent just totally write the whole thing for us, okay? So let's build a DApp, I guess, decentralized app that asks, how's the vibe? Let people click good or bad and vote in the contract. Make sure there is no owner or way to reset the vote, and display the vote on the front page, please. Something like that. You got to say please for when the overlords take over and, you know, you want them to take mercy on you. Okay, here we go. So here we go. Hopefully this agent is going to one-shot this voting app, and we're going to put this app on chain in a way where the code is law. It can't be changed. Anybody can audit the code and see that how the vote works. They can see that there's no owner. They can see that there's no way to change the vote. And everyone can see how everyone votes, which is kind of bad. That's kind of an elephant in the room. You kind of want your votes to be private. There's a couple things that need to happen here. You need civil resistance and privacy. Those are coming with different types of proof of humanity and different types of ZK circuits. We can get both of those things, but let's pretend we have privacy and we have civil resistance. This is going to be a very good way to to capture a vote for like a presidential election or something, right? We can see if people have voted for good vibes or bad vibes. We can see, we're keeping track of has someone voted. And then when they do vote, we make sure that they haven't voted already, right? We do some checks here to say, has this person voted? And then if they haven't yet, we count their vote and we mark them as voted and we increment the good vibes. So it looks like it has built the smart contract already, like much faster than I could have done that myself. Now what we're looking for is this home page to reload. We're looking for it, and it looks like it's writing the page right now. Let's let that finish, and then we'll deploy this thing. We'll one-shot this thing all the way to mainnet. But now is a good time to start asking questions. I think I'm basically done with my presentation. Go to Speedrun Ethereum and learn how to build on Ethereum. Use Scaffold-ETH to build some apps. Ask questions in the chat, and I can answer them as you continue your journey. Another good resource is Solidity by Example, and also Cypherin. They're another piece of education that I would recommend. Solidity by Example just has all these like basic Solidity examples. And you can, if you're a good programmer, you can take Scaffold-ETH and Solidity by Example and basically learn all the syntax pretty quickly. There's example apps and even example hacks. As you start getting really good, you want to go and be able to reproduce every one of these hacks. You should be able to create a smart contract that has reentrancy as a vulnerability and then re-enter it with an attacker contract. And that will get you closer and closer to building secure contracts. But I believe our voting app is there. Let's make sure we can vote good. Okay, I'm going to open this up in an incognito window, and it's going to give me a different burner wallet. Notice we have like the pink and blue guy over here. Whoa, it's doing stuff. Stop. I think it killed our yeah, let's kill that and start back up. Sometimes it's like, I'm going to run your web server for you again. I'm going to deploy your contract for you. So sometimes the agent goes off the rails a little bit, but let's let this spin back up. Basically, I want to vote with one account and make sure the good vote works, and then use another account, an incognito window, to vote bad and make sure that gets counted, make sure there's no censorship happening here, and then we'll ship this thing. Okay, it's good. So we get a new wallet, we grab some money from the faucet, now we got some funds, now we vote bad, make sure that increments, and we're good to go. Okay, it looks good. Let's consider this thing audited. Of course, if you were putting something on mainnet, you would audit the heck out of it, but let's deploy this to some live network. Now we could go to mainnet, right? And that would deploy to mainnet Ethereum, but that would cost me like a couple of bucks. I'm gonna be kind of cheap, and we're gonna put it on an L2. Ooh, what's an L2? Okay, so if we go to L2 beat for a second. So an L2 is like a little baby Ethereum where all the execution gets rolled up and settles to Ethereum. And if anything ever goes wrong, you can exit back to Ethereum. So it inherits the security of Ethereum, but it runs in a fast, cheap environment that allows you to do things like more mainstream things like run a social network on chain, right? So Arbitrum, Base, Optimism, Linea, these are all L2s of Ethereum. And if you put money into Arbitrum, and even if the creators of Arbitrum and everyone else wanted to take your money and shut you down, they still couldn't. You could always exit your money back to Ethereum. So these kind of inherit the security of Ethereum. There's some gotchas here where I think the exit window is like 10 days on Arbitrum. And so to get a full green pie, I think it needs to be like 2 hours or something. I don't know exactly what it is. But so there's some decentralization gotchas here where Ethereum, if you need something to be hella secure and hella decentralized, deploy it to Ethereum. But there's these L2s that run cheap and fast and settle to Ethereum and inherit the security of Ethereum. And even if they go completely down, you can get your money out of them. Let's deploy to this one because it's on the top. Let's go to Arbitrum. Okay, and so it's going to be a lot cheaper. It's going to cost me like a couple of pennies to deploy this. Okay, looks like I need to yarn generate, and I will create an account real quick. And it wants me to put in a password for that account. Okay, so that just created a new private key. It encrypted it and put it in some storage. So I have to send a little bit of money here. Let me do this real quick. And then we'll go send. And we'll go that address. And we'll do some Arbitrum ETH. And I'll send in like 0.0001. That's probably too much. 0.0005. That's still probably too much. 13 cents. 13 cents. I bet that's enough. It probably is going to cost 2 cents to deploy the smart contract, and to interact with this, it's going to be like a fraction of a cent. And also, this is like almost immediate, right? This is so gross. Look at this. It looks like I'm sending $6,000 right now. Look at that. Why does it do that? I think that's a bug in the wallet. I just hopefully just sent a tiny amount, and like money would disappear here faster. But this is Web3. This is the Wild West. It makes it look like you're sending all your money for a second. I don't know why the Rainbow Wallet does that. Okay, so hopefully we have some money in here. We could even go look at this on like Address Vision. It should have like a few cents on Arbitrum. We'll go to Arbitrscan. Yep, we've got 13 cents. Okay, now let's yarn deploy. Whoa, yarn deploy -- network Arbitrum. Here we go. I'm probably going to have to put in that password again. Now let's deploy that contract. Hooray, there we go. How fast was that? It just deployed the contract, right? We can even go look at that transaction. How much did it cost? We sent in the 13 cents here. We deployed the contract here, and it cost us 2 cents. Really, really not that bad. Not that bad. Pretty cheap to deploy a smart contract that's going to be there longer than I will, and no one can take it down. Okay, so in our app, we're almost ready. I need to jump to the Scaffold-ETH config, and I need to tell it we're not on hard hat anymore. We're on Arbitrum. Arbitrum. Save. Now, here's what happens. Our whole app updates, and now it's on Arbitrum. And let me get this started. I'm going to yarn IPFS. So I'm going to basically upload my front end to a website too. So now I'll have a live URL where y'all could get in here and vote if you had some Arbitrum. Okay, so let's connect our wallets to our live app, and we could vote good in there. Oh, I need to be on Arbitrum. See that whole network switch thing? That's why the burner wallets are nice. So I need to switch over to Arbitrum 1. And by the way, if you're building an app, Scaffold-ETH is really good for this kind of stuff. It totally like switches you over to the right network and does all that stuff. Actually, I'm just going to let this. Oh no, something weird. Let's fix that real quick. Okay, this is where the agent is really nice, right? I can just drop this in over here and be like, bro, fix this, please. There's some kind of syntax error where I have this quote and it's being escaped with the wrong thing. And I need that to be fixed real quick. Oh, okay. I guess it already fixed it. That was very fast. Thank you. Yarn IPFS. Now let's see if this uploads. Okay, another thing. Let's go look at the smart contract real quick. Oh no, did the front end go down? Okay, maybe we need to, I'll just wait for the thing to deploy. Let's go look at the smart contract real quick. If we go look at this address, we can see the smart contract that was deployed. Right now, it's just going to be a bunch of bytecode. If we go look at the code, it should show, here's the contract that got deployed. It just looks like this, right? So what you have to do is verify that code. And I don't know if this is going to work either. Sometimes this works, sometimes it doesn't. Basically, to verify your code, you upload your smart contract, and then they compile it and make sure they get the exact same code. And if so, then they replace your bytecode with the code that they use to compile it. So now it looks like it worked. Now if we hit reload here, there is our voting contract. How cool is that? So it's totally open source. We can see exactly how the vibes are counted. We can see all the transactions that are made on this. We can see that no one can reset it. So this is a great way to take a fully decentralized vote. And look at that, we've got a front end too. I'm gonna paste it into the chat. In case anybody has some Arbitrum laying around, you can actually vote on the vibes, but I'm gonna do that too. Let's go. So this is on IPFS. So the actual front end is hosted in like this peer-to-peer way, and you can ask any node on the network for this specific hash, and it will give you this whole front end. So even the front end is sort of distributed, if not close to decentralized. If someone tried to shut it down, it would be hard if you had this on lots of nodes all over the world. And in particular, if you provided incentives to keep it up, then it would stay up even longer. This is a lesson learned here. For decentralization, you need really good incentives. Okay, let's connect our wallet. Let's vote on good vibes. This is a great time to be asking questions. Get in the Telegram channel and ask questions. Here's the Telegram channel one more time. Where is it? I don't have it up anymore. Get in the Telegram channel. Okay, we're going to switch to Arbitrum 1. Here we go. We're going to vote good vibes. It pops up a little Wally connector, and it's going to say it's going to cost you about a penny. It's probably less than a penny. We can go look at it. And there we go. We just voted. Let's see if it, oh yeah, I just got a notification that I just made a transaction on Arbitrum. I think the reload time might be 30 seconds. I needed to change that too. I needed to change this to 3 seconds, and then it would have reloaded faster. But there it is. Good vibes. We voted. Anybody can now connect to this. They can go to this address on IPFS. They can ask any node in the IPFS network for this, and they'll get the front end. They can vote by making a transaction with their wallet, and it will go to a smart contract where it's tracked here in this smart contract where the votes are, and everyone can see the votes, and everyone can query this contract and get the current vote. So it's decentralized. No one can take it down. No one can tamper with it. And we basically vibe coded it in like 10 minutes. So this is how you build on Ethereum. You can use Scaffold-ETH to build these kinds of things. Of course, if you're building something more intricate, you're going to need more audits. You're going to need, it's going to be harder. You can't just one-shot it. But let's go look at the transaction. Let's see my vote. We can go see, let's see, this contract. Wait, that's the contract creator. We need to go to the contract that it created, and then we need to look at the transactions. There we go. So look at it, there's the vote. Good. It recognizes the method because we've uploaded the code. It knows that Austin Griffith called vote good. And how much did it cost? Let's find out. There you go, 0.0004, so less than half a cent to vote. So that's the joy of these L2s, is we're getting closer to like mainstream audiences could maybe pay half a cent for a transaction for something important, right? And then there's like L3s, and there's sponsored transactions and ways to make that even cheaper or even possibly free. But there we go. We deployed an app to a blockchain, and this is what building Ethereum on Ethereum is all about. You're building apps that'll be there forever that no one can take down or tamper with. And TLDR, they're like coordination mechanisms for pirates that don't trust each other. Okay, cool. Any questions? Now is a good time. If you want to unmute the mic and ask, or drop it in the Telegram, or even if you have a question in a year, you can come back, search Build Guild, EF, Penn, and you'll find this channel. It's Biddle-Giddle too. It's spelled all jacked up, but that's like a HODL meme and a Biddle meme if you've been in the space for a while. Yeah, any questions? Watching the chat, feel free to unmute. I'm gonna quit yapping.
I think they'll probably, and thank you for the awesome presentation. I think they'll probably start coming in over the next couple hours or days. People are just wrapping up.
Heck yeah.
But we've gotten we're getting a lot of nice commentary in our like internal chats. People are really happy. So this is a great presentation.
Who is this crazy guy? Yeah,
no,
yeah.
It's like
hearts.
We love it. Yeah, and we'd love to stay in close communication. This is awesome. We do this again.
Great. Yes, you have my connection. I work at the Ethereum Foundation. If you need anything, let me know. One day when you are building your thing and you're raising money and you have an awesome app and you're about to get rich, come talk to me and I can help there too. I haven't successfully gotten rich either, so maybe I'm not the person to talk to, but I can get you to the person who can get you set up. But thank you so much for having me. If you guys have questions, drop them in the Telegram later on. I'll be around. If I'm in charge, I don't know who created this channel, but I think Sean did at the EF, so I bet he has control of the recording, but I'll figure out a way to get the recording and get it into this Telegram channel for y'all so you can share it too. Yeah, I don't know if there's anything else. If you have anything else, now's the time to ask. Go speedrun Ethereum.
Will you be at any conferences this year? We're headed out to Argentina.
Definitely Argentina. I'll take a whole crew to Argentina. In fact, devconnect.buildguild.com. I will probably give a presentation very similar to what I just gave at DevConnect. It's kind of the thing I do, building your first app on Ethereum. That'll be me. But then we'll go through each one of these challenges, like the stablecoin challenge, the prediction market, the zero knowledge proofs. We'll have other people there helping to teach. I'll vibe code a game, and then we'll have a giant CTF, a capture the flag. So if you've gotten good between now and then, there will be some money to win here, probably like $1,000. You'll take on a bunch of challenges. So come join us for the CTF, the speed run. We'll be in Argentina. I go to most conferences. I mean, not all of them, but I try to get to a lot of conferences, especially like the ETH Global Hackathons. So yeah, I'll be at a lot of them. So look out for me.
All right, we'll be there too, and we'll be hacking. So we'll come find you.
Amazing. Awesome. That's awesome. Well, it's great to hang out, Penn. Go learn some stuff, go graduate, and then go build some cool things on chain that gets users.
We will. Thank you so much, Austin.
Awesome. Thank you.